All right. What does potassium do for photosynthesis?
Isn't it the overall growth of the plant?
Potassium, yes, general health of the plant. The one that does stems and leaves helps the
That's
stems
the
and leaves.
nitrogen?
Is it nitrogen? Or the general consensus in that area?
Yeah. I think, or is it phosphorus?
What are kind of the three elements?
Phosphorus and
Phosphorus, potassium, and nitrogen. Yes. Yeah, nitrogen does do the stems and leaves. If you have a substance that is composed of only one type of atom, like say for example hydrogen or oxygen, what is that? What would you call that? Compound, an element, a nutrient, or phosphorus. So, let me see, that should be on question, I found my answer key, something's happening. 2.1 what? Which one did you do last? 1.4?
1.3.
3.
So I guess you're updating the chapter review.
We'll briefly look at chapter, probably some. We'll probably try to pull the chapter review and the test together. The one event is a portion of the class. All right, so, because basically I want Christopher over here. All right, can't find it. Why would they talk about it and not do anything about it? If you're talking about an element, why would they have a question like that and not have it anywhere in the work? Yes, a substance that is only one type of atom. So you know what an atom is, correct? The atom is the smallest particle of anything you can have. So like, you get smaller than even a cell. Like a plant cell is made up of millions of atoms. Like that's the size we're talking. Very, very, very small. So you have something that's only one cell, one particle is an atom. If it's only one type of atom, then it's an element. So calcium is an element, and actually phosphorus. A little confused why we wouldn't have talked about this in the, seems like let's go back here. Nutrients, there we go, element. It is a definition, beginning of 1.3, top chapter, or top of page 12. It says, plants remove these three elements, which are nitrogen, phosphorus, and potassium. They're called elements. Building blocks of everything. Yeah, those are the primary plant food elements. What are they again? Nitrogen,
Potassium, nitrogen,
potassium, and phosphorus. Phosphorus. That's a fun word. Phosphorus is the sun. It glows. Or can. Like Christopher Columbus when he was sailing. Well, he wasn't sailing to find the New World, but when he did, he was down off the coast of Florida. There's little phosphorescent microbes, little itty bitty varmints. Basically, you drive your ship through them, and it stirs them up, and makes them glow. Phosphorescent.
That's cool.
It is cool. All right. What else do we have? Oh, there's a check. Number 1.3. Right? Yes. Yes.
So, are we gonna check that? We're gonna check the work last time.
Where's yours?
I can't find it.
All right. Well, I can't either. You can't. What are you gonna do about it?
I don't know.
I have to come up with all the solutions?
What?
I have to come up with all the solutions?
That's what teachers are
Well, I'm open to suggestions. I need to see some kind of, so if you don't have it, we have
for.
to make it.
Do it again.
Nitrogen, phosphorus, and potassium. Right? Number 2 is phosphates. Number 3 is nitrogen fixing bacteria. Number 4 is nitrifying or nitrifying bacteria. Number 4 is, yes.
So bacterial benefits is not really.
I don't believe so.
Huh?
Let me look and make sure. Oh, you know what? I hope they're,
No, some of mine are right, but number 4.
yeah, hang on just a second. I'm just making sure that this, with all the mix-ups we've had regarding our, yeah, this is which bacteria convert ammonia to nitrates?
Is it
And that would be,
bacterial benefits?
no, probably not, nitrifying bacteria. 5, which bacteria put nitrogen back into the air? And that is denitrifying bacteria.
I have plants.
Which bacteria? Specifically, so you can count all of them. 6. What do you have?
Cell division and growth.
Cell division and what?
Growth.
Growth.
It makes plants fruit burn up properly. It loves plants, bacteria.
Maturation. Those are both good.
Maturation.
Yeah.
So
All right,
that's good.
there's 4 options. You need to have 2 of them. I will say the 4. Cell division. Plant maturation, which means helps it to get to its grown-up stage.
So then that's right.
That one's right. Makes fruits firm up and promotes energy transfer.
Let's have some more plants.
I make it produce.
Maturation.
Makes it produce and helps you grow. You should be pretty specific, I think. So in producing, okay, it helps it grow, that makes, so that kind of goes with essential for cell division. But make sure you have it as essential for cell division. So let's just add, don't count wrong with add.
So I have cell division and growth.
Cell division and, see, the problem is they're basically the same.
So I have one or
Count one wrong, I'm gonna count these as, yes.
So what I have from other plants, maturation, whatever, that's right.
Yours is correct, yes, and the firming up. So you have those 2, that's good.
It makes
Yours is all right.
burn up properly.
Yes, yours is good.
I have photosynthesis and
That's energy transfer. You're good. Yes, so as long as you have 2 of those, that's the deal. All right. And that was all I made to do, or did we do 7 as well? 7 as well? All right, the 3 ways that potassium benefits plants. There's 4 options. What do we have? Yeah,
it is like
say again?
better sized fruit.
Okay, yep, root growth and fruit formation they have as one. I can split that up.
I just have encouraged root growth. Yeah.
Yeah. I can split those into two.
That improves disease resistance.
Yes, improves disease resistance,
I contribute general health of.
contributes to annual health, it's also a good one.
And then 3, fruit formation.
Fruit formation, root growth, disease resistance, contributes to general health, and also,
Fruit formation is good then.
Yeah. and also helps regulate water balance. Not 5 things. All right. Just as a general thing, what does lightning do?
It,
Makes fires.
I'm thinking good for plants. Usually, not in the air.
usually rain comes with lightning.
Also true. So here's the cool thing. The air is 78, 75, 76. I'm going with 76 because I like that number better. Percent nitrogen. I can't remember exactly. Most of the air we breathe is nitrogen. It's like 15% oxygen. It's pretty low. Oxygen, carbon dioxide, and a bunch of other gases make up the rest. But the air we breathe is almost, well, if you were to have a circle, this is the nitrogen, the old pie graph trick. And this little slice right here approximately could be oxygen. And honestly, a big chunk of it is carbon dioxide, and then this is all this other stuff. Most of the air we breathe is nitrogen. So what happens is, you get a lightning flash, and all that heat, electricity, turns the nitrogen from the air into a solid. All that heat and energy, it goes down to the ground. So, lightning puts nitrogen into the ground and makes nice growth. That's what it does. So if you didn't have lightning, eventually, you have to start putting liquid nitrogen in the ground or something in order to grow anything, which people do anyway. All right. Some of the things, actually, let's do the quiz first. Five.
Oh, are we gonna get a grade for like 1.3?
Yes, it's 10 points off for each one you got wrong. If you have 2 wrong, it's an 80. If you have 1 wrong, it's a 90. If you have 3 wrong, it's a 7.
Are you just gonna check this?
Yes.
I did.
I'll have it handed in.
This lesson, back here.
Huh?
What about on the side?
What more? Which?
No, this going in today.
I'll worry about those. I'll have to talk to you about that eventually. I'm gonna have to talk to you right now. But yeah, we're going to basically, if they're less than 10 points, this is probably barely fair. But I will do it for you anyway. I don't like if a section has less than 10 points. So if there's less than 10 questions, usually try to divide them up so that in the end, you have a total of 10 points. So if you have 1 wrong, pretty much, unless there's like 15 questions, which is fairly rare in science, is gonna be about 10, I'm gonna count it as 10 points apiece. So if 1 wrong, it's 90, 2 wrong, it's 80.
So I can just say that this
So you
one's
can,
90 then.
yeah, exactly, you can say that one's a 90, and that's fine. That's how it's going to be, just pretty much for most of the sciences here. Because basically, the questions range from 6 to 9, barely ever get over 10. We're counting it as 10 points apiece, just for simplicity's sake. And also because if you have 5 questions, you get 1 wrong, you automatically have an 80. If you have 2 wrong, it's automatically a 60. And that's not good. On the other hand, if you have 6 of them wrong, 5, if you have 6 questions, you have 5 anyway, still not good for you, so. We're just trying to overcome that obstacle. All right, plants have a lot of things going for them. This is the only place that we know of, for Earth in general, that we can grow. I forgot what it was. A nourishing substance. This is also a 10 question quiz, so they're getting one piece.
A nourishing substance.
What do you call it? Ammonia, nodule, nope, my bad. Compound, element, nutrient, or phosphate.
Nutrients.
You call it a nutrient? That's a nourishing substance?
Yeah.
Good enough for me.
We're doing 1.3 today. We did.
4. We just checked 1.3. Don't worry. You just-
We're gonna do sure, I did do it.
The quiz is 1.4. Well, you checked it, you had answers, so I hope you did.
No, but then I must have did that one. The last time, didn't I do this?
That's 1.3, we did, we just checked that.
No,
Now you start here, we're 1.4.
maybe I'm not mistaken.
Nope, I think
Maybe
you're
I'm
good.
just mistaken.
Well, that'll happen, especially when you listen to me long enough. Yeah, nitrogen fixing the bacteria. They convert atmospheric nitrogen, which is, atmospheric just means nitrogen in the air. It's a fancy word. They convert atmospheric nitrogen to nitrogen compounds. So nitrogen fixing bacteria makes nitrates and what? Ammonia, nodule, oxide, of potash. You better know, it depends on the quiz.
Potash.
Potash?
Yeah.
Are you
And
sure?
that doesn't sound right.
Well, let's look.
So,
Go back and look in 1.3, where does it find nitrogen fixing bacteria? And tell us where you find it. What does nitrogen fixing bacteria do?
Other nitrogen compounds? Other nitrogen compounds?
Other nitrogen compounds? What are the nitrogen compounds?
Ammonia.
Ammonia.
Uh,
There you go. Nitrates and ammonia. Yeah, and which plant food element grows stems and leaves?
a plant.
No, which element? So it's phosphorus,
Nitrogen.
nitrogen. Grows.
Potassium.
Mm,
We better find this out.
it's nitrogen.
Where'd you find it?
It's fine.
Yeah.
Yep,
it's-
that's nitrogen.
So nitrogen grows stems and leaves. You're sure?
What it says.
All
So I'm gonna believe
That's
it.
why if you don't have nitrogen, your plants don't work either, so. Also, if you take, oh, crumbs. This period always goes away from me. Oh, well. Basically, yeah, if you have plants that aren't growing, they're kind of yellow and sickly and droopy, shoot it with nitrogen, liquid nitrogen or whatever. You can't give them too much nitrogen, then it'll just burn off at the top of the ground. Yes. Leaves and stems, and then they shoot up really fast. Alright. Yes.
What's a failing, like, when I have to redo that?
4 wrong. No, 3 wrong.
Man, I might actually have to redo this one.
I hope not. It hurts my feelings when you do that. You kind of know, are we almost stable?
I guess.
Maybe open book,
Good idea.
since there's
It
so
does
many.
feel like we did not study on this, right?
So that makes you think that we know.
Do this one with the books. You hold this. Go.
Similar to meristematic tissue,
I think so. What is meristematic? What is the question?
organic tissue forms a majority of the. It says
We'll check those here. We'll check those right here. Pass those to the. You done?
Yeah.
3 is B, 4 is C, 5 is A. 6 is A, 7 is F, 8 is D, 9 is E, 10 is G.
Okay, so 6 was A, and then 7 was.
Yeah.
And 8 was.
D. 8 was B, 9 is E, 10 is G.
Just to eliminate.
So, 2 on 8 is. It's kind of a, I feel like they're trying to push it too hard and fast here, but that's all right. All right. You can hand those in, make sure they have names and dates on them.
You just got it on date.
Names
I
and
fixed
dates.
that.
September 20th. All right. Hold that. Fantastic.
Mr. Tim,
Feel
I
like-
took that. When I put in
Say again?
I took that when I was putting.
Oh dear. It's cockeyed. Somebody's getting a shot of me. All right. We're talking about water and air. Turns out plants need air. They need air actually here by the roots and also up here, obviously. And if you overwater a plant, what happens is the water fills up the air pockets around the roots. Basically, the roots need to breathe as well as the rest of the plant. So if you overwater a plant, there's also no water there, and it will actually wilt and die. Some plants are more susceptible to it than others. You can pass the straws around. They have a purpose. Yeah, so if there's no air available to the roots of the plant, they will suffocate. And that's why clayey type soils, you can actually, like, you have to be careful not to overwater, and then it can be worse than sand, because sand will drain, and also has bigger holes in between the sand grains. Important thing, capillary action is an important thing, or capillarity. Capillarity is, have a clear straw, which I've searched for a clear straw, there's one I couldn't find. If you have a glass of water and a straw going into it, the water level in the straw, sometimes you gotta look at this, if you ever get a hold of a clear straw, but the water level in the straw will actually be slightly higher than the level. The reason for this is something called capillary action, and the smaller the straw, the higher the level. So if you have a really, really thin straw, whoopsie daisy, that one's so thin it cut itself, the level will be higher. Every plant has these little veins in it, represented by this, called xylem and phloem for the biology class. And they basically suck water up. There's also something on the bottom of the leaf, which I'm sure, I was looking at my microscope going, I got my microscope this weekend. And I turned it on, it didn't work. I was offended. Still am, as a matter of fact. But I quit calling people bad names, and I began to try to love them. We're having a conversation about how to make the problem go away. Yeah, basically, that's what you call the upper movement in a tiny straw. It's capillarity or capillary action. I will accept either answer. What is non-porous? Give me an example of something that's non-porous.
Something that's hard maybe, I don't know.
No, possible. What are pores?
Pores,
Pores. What's pore?
something in the planet.
Something that allows to.
On the bottom side of the leaf, it helps it breathe.
You're on the right track. That's a stomata. That's not a pore.
Thing that lets you sweat.
Well, also true. We're not talking about sweating. So a porous material is a material that has kind of gaps in it, like, well, foam. Think foam is a porous material. So there's kind of air gaps in it. A non-porous material, a really great example is, say, glass is a non-porous material. Or most hard plastics tend to be mostly non-porous. The non-porous things are very smooth. They also don't absorb water. They are usually pretty hard. But you can also have like rocks that are porous. And so on and so forth. There's something, so water does some interesting things. Water drains, obviously. If you were to study some water for 100 years, if you were to study some water, look at a water drop or molecule for 100 years, it would spend 98 years in the ocean. 96, 97,
98.
98. It would spend 20 months. Where does it say this? I thought I could do this by memory, but I can't. It would spend 1 week in the atmosphere, I think.
Yeah, but
Yes, there you go.
like, once you put it in the ground, or something like that.
2 weeks in rivers and lakes, 3 months in the ground, it's actually underground. And 20 months is ice, 98 years in the ocean.
But how do you get from the ground into the ocean?
Often it gets pumped out, or sometimes it just drains out. Like, basically there's layers of rock, you know that bedrock we talked about? Groundwater doesn't often go down below that. What we call it impermeable rock. I'm not sure exactly where they're getting all their numbers from, and I'm not sure exactly how all of this works. But there's these layers of rock that can kind of trap water. And it's kind of a big deal around here, especially if you can find out where the water is between these layers of rocks. If you can drill down to it, you can have lots and lots of free water, which is a good thing. However, it's a little sketchy and hard to find because not everything is two-dimensional. There's always a third dimension somewhere. You gotta get down to it. Anyway, but basically there's bedrock, and impermeable rock means if it's impermeable, it means that water can't get through it. So it's trapped between these two layers of rock. I do not have the time to finish the rest of this. I want you to read it and do 1 through 6. For me, please. On Thursday, we will hopefully do this experiment. We've never done it before. We'll do it again.
What is it?
The one with the celery.
1.4.
Yes.
What do you do?
Are we?
You read the experiment. Yes, you do it.
Bye, Jesus.
Hopefully do that experiment on Thursday. I can get this clutch and saw, do the things. Very so sure if you want clutch or more saw. All right.
So you said that whatever, that term,
Capillarity.
this right here, non-porous, non-porous.
Mm-hmm.
It can let water through or it can't.
Non-porous cannot let water through. The water encounters a layer of impermeable bedrocks. Impermeable means you can't let water through. All right. What are the three basic leaf shapes? Say again?
Broadleaf is one.
Okay, broadleaf,
Long tail.
long,
Yeah, like a new.
scale like needle. So they say the three, so which ones are they shooting for here?
Are we checking?
Yes,
That's what broad, long, and middle. Oh, yeah, that's why I have two broad and flat long hair.
middle I can scale like thrown together.
Yeah, that's sort of the same.
So,
Size and texture too. And size and texture.
yeah, exactly, that's the second part of the question. And what are the ways do they vary from plant to plant? 2. Distinguish between all opposite alternate world and rosette. Help me.
Opposite, two leaves grow from each, nod, and ODE, I think.
Nodule,
Sure. Just ODE.
node.
No. And roll is when there are three or more leaves. Compare themselves with each other.
3 or more leaves from each node winds up being a whorl. What rosette?
Alternate is the one, one leaf from each.
One leaf from each node. Basically, in a practical standpoint, the stem alternate is like this. You get leaf, 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 leaf. Opposite is like this. What about whorl? It's 3.
Yeah.
Okay. What about rosette? And more than
And the leaves grow and cluster on the base of the plant.
down here.
Yeah.
Dandelions. Well, that's probably a pretty good example of rosette. All right. How do leaves orient themselves so each blade is about 90-degree angle? The source of light. The petiole actually moves. So say for example, yeah. So it's that little stem part, right? Right here, twists and turns and tries to orient itself to 90 degrees to the light. Why would one do that?
So it can reach for the sun. So it can use the sun to make food.
How would that help?
So it can have photosynthesis. Yeah, if it has food, then it can stay hot like that. I'm gonna put food down.
All right, the reason is because they're more efficient if they're at 90 degrees to the sun. Like if you ever watch solar panels, like one across from Phil's, those things tip through the day. So in the morning, they're pointing toward the sun, in the afternoon, they're pointing toward the sun. They're actually they have to do the same thing, they have to tip to always face the sun. Leaves wind up doing the same thing. So what I'm saying is, so here we have the sun, orange. So if your leaf is like this, the sun's rays just they can kind of deflect off of it. Not so much as sunlight. But if it's turned straight at the sun, it'll actually absorb more. It'll reflect less. So that's why they turn to 90 degrees. But it's so that they're more efficient, so they can make food faster. Because what do plants actually use mostly?
Like,
They use light to make food, which is really pretty special, when it comes right down to it. You can't use light to make food. You have to use plant to use light to make food. All right. Here again, I was gonna have you guys view these leaves through a telescope, through a microscope today, which my life has taken a turn for the worse. Also, what kind of leaf structure would this be? We call this alternate. Yes. One leaf from each node. The three types of structural tissue. So three types of tissue. All right, what was the first one? What are the three types of tissue? We're going to be dealing with a lot of big words, and I'm trying to simplify it as much as possible for you. What are our three types of tissue?
Magnesium.
No.
Structural.
I just put it down.
Probably.
Hey, we didn't finish checking. Yeah, we did. No,
Oh, you didn't know before too?
yeah.
In a paragraph.
We've got a paragraph.
You have a paragraph?
Yeah.
Yeah.
Got a paragraph.
All right. What do you have? What do you have?
Simple leaves are longer and the compound leaves are more than one letter in the area. Each small layer and compound leaf is referred to as a leaflet. The petals can be identified by the presence of a violet ring where it attaches to each branch. If each petal is attached to one of the leaves are simple. If each petal is attached to several leaflets, leaves are common.
Good. Very thorough. Appreciate that. What do you have, Lisa?
Simple leaves, one blade on every petal. Compound leaves are more than one leaf on every petal. Each small blade on the compound leaf is referred to as leaflet. Each petal is attached to one leg. The leaves are simple. It has several leaflets. It is compound.
Okay. What do you have, Christie?
Leaves may be classified as either petal or compound more than one. The petal can be identified by the presence of a bud at the end where it attaches to the branch. The other end of the petal will be attached to one or more leaflets. There are no buds at the point of the attachment of each leaflet. If each petal is attached to one leg, the leaf is simple. If each petal is attached to several leaflets, the leaves are compound.
Yes. That's good. Anybody have any wrong? Good. No, worry about grades. All right, structural tissue. So it says there are four types of structural tissue, which you actually have to know. All right. Let's go over this. Try to keep this as simplified as possible. Plants are made up of three kinds of tissue. One of them is good black marker. What do you mean? I don't like all these silly colors. All right. Structural,
Is it on the table?
probably.
It's over here. It's on your desk.
Oh, okay, there's one by my computer there.
There's one right beside your oil can.
No, that's not a good black marker, that's a black marker. Vascular. And what's the other one? Epidermal. So I'm gonna try to break this down a little bit. Or try to give you things to remember it by. Structural, like, basically think building blocks. So like if somebody's building a structure, they're building, think 2x4s and concrete and the things, the big things that kind of make up the bulk of the building. All right, so structural material is kind of the big, kind of the filler stuff, but it's the stuff that holds it up. It's the stuff that keeps it vertical and whatever. It's the stiffer, harder stuff. They're going to say there's different types of structure. We're gonna breeze over that for a little bit. And we're gonna go on to
I think the third one is mercenatic.
over-somatic. Oops. my
Because
bad.
epidermal is a structural.
Yeah. No, I think you're right. Where I saw that. What, you said meristematic? Yeah, that reminds me of doing the right thing. Thought I studied it. Vascular means, okay, so up here for structural, think 2x4s. Vascular, what a vascular system is it's, think blood vessels and veins and arteries. Consists of something they call xylem and phloem, which I made a model. Kind of. What is xylem and phloem? What's the difference between xylem and phloem?
Xylem contains with water dissolved in the upward from plasma. Transports food manufactured in wood.
All right. So the xylem is going up, the phloem is going down to the roots, right? So xylem, which ones would be on the inside of the plant? Usually there's, like if you would look at a plant, there's kind of an inside and an outside. But you can see you can usually, like if you cut a plant open, you can see dots and things. That's the vascular system you're looking at. The stuff inside, toward the center of most plants, is the phloem, usually. And the xylem is usually in the green part of the plant, usually toward the outside. And as the plant grows, it keeps adding on to the outside and getting new xylem, and some of the old xylem turns into phloem. Like as it gets old and stiff, it just starts to transfer stuff back down to the center. And what is meristematic? It includes, what could meristematic stand for?
Growth and repair products.
Right. So if you wind up starting to chop a tree down and stop halfway through, you'll try to repair itself. It'll try to grow back strong. And that would be the meristematic. Also, the new growth is meristematic. It makes new vascular tissue. It can, it's something called vascular cambium. Cambium is, so many big words. I'm trying to figure out how to break this down. Yeah. There's basically, cambium tissue is internal. It's inside, and it helps things to grow. Where basically, yeah. Meristematic tissue winds up being in spread out evenly through the plant, like structural and vascular stuff is more. It winds up being like in the tips of the roots and the tips of the branches going out and bud. So that's where you find meristematic tissue. Leaf structures. There's stomata on the bottom of the leaf. What's that for? What is a stomata?
It's tiny.
Right, it's a little hole in the bottom of the leaf. That's what I was hoping to look at today, but well, here we are. You can kind of see them with a magnifying glass, but not super well. They're controlled opening and closing. Basically, if they're open, it means that evaporation is going on. It's actually pulling water up to the plant. So say, for example, that, well, a cactus would have stomata, well, anything else. But a cactus might close its stomata during the day and open them at night. Why would that happen? Say what?
Where would it be?
Have lots of cactuses.
It would have fewer stomata than some things, but they're such small holes you can hardly see them. Yeah, I know, I've seen them through a microscope before. They're on the bottom side of the leaf. I'm not having any luck. It says like an oak leaf can have 100,000 of them per square inch. And I'm guessing desert plants, they wind up being a lot harder to see than on some of the, yeah, like the one being smaller and probably a lot more scarce on a desert plant, because otherwise it'd run through too much water and they just die. That's why I'm so angry about the microscope. Anyway, I was hoping to spend our whole class time basically doing microscope stuff. Here we are. All right, what's an epidermis on a leaf?
That's covered in protection for.
What's your epidermis? Derma means skin. In the Latin word for derm. You know, you know about root words. Derm means skin, so an epidermis, top and bottom epidermis is the skin on the leaf. All right. Do your thing. You did study your biomemory, right, Richard? You did study your biomemory?
No.